Yes, good afternoon, class.
Good afternoon, sir.
How are you?
We are fine.
You are fine?
Yes.
Okay, good. Before we continue, I want us to take the roll call. Before we continue, Anne Chentai,
Present.
Victor Namoya, Amos Wekesa, Christine Juma,
Present.
Ruth Sibiu.
Present.
Very good. I see the turnout is okay. That's very interesting. Now, today being Monday on 19/12/2024, I want us to have a recap on what we did last week about eigenvalues and eigenvectors that we did last week. Now, who can remind us what are the eigenvalues that we did last week? This is just a recap. Who can remind us? By show of hands. Yes, Anne?
We did eigenvalues and eigenvectors.
Very good. We did eigenvalues and eigenvectors. Those are what we did last week. Now, today, on the same, but we are going to do something under the same but. Before that, our outcomes, our objective that we need to meet is number one, we are going to define the term matrix. Another objective, we should make sure that we are also meeting the addition and subtraction of matrix. That is our learning outcome today. Now, that one being our subtopic that I want us to deal with, first we want to know what do we mean by this term matrix. What do we mean by the term matrix? Now, the definition of the term matrix, who can try to attempt and maybe answer that question? Who can just try? Maybe it may be a new concept, but who can try? Okay. Now, when we talk about matrix, this means it's a rectangular arrangement of numbers in a row and columns. This means we will arrangement of elements in columns and rows. Whenever we arrange elements in columns and rows, that means that we are dealing with matrix. Now, you may ask us, you may wonder, what are we talking about the rows? Now, we have the rows here, and also we have the columns. Now, the rows, when we talk about the rows, this is the horizontal line. Rows simplify the horizontal line, then the columns is the vertical line. Are we together? Very good. Example, when we have a matrix like 2 by 2, this is a matrix. But when we want to represent this matrix, these elements as a matrix, we will have 2 by 3 matrix, whereby now we will have the elements, being arranged in columns and the elements being arranged in columns. For example, we have 1, 2, 3, and 4, 1, 3. This is a 2 by 3 matrix. Why? Because the rows, this is the first row, this is the second row. That's why it is 2. Then the first column, the second column, and the third column. So now that's what we mean by the 2 by 3 matrix. Are we together?
Yes.
Very good. Now, number 2, we have the application of this matrix. Most of the time, this matrix is being used in mathematics for solving equations, and also in computer science in representing the graphs and the images. That's being used most. Then also from there, we move down to now addition and subtraction of matrix. Number 2 is going to be addition and subtraction of matrix. Now, when we talk about addition and subtraction of matrix, this means that we have the elements in a matrix, but we will be adding the elements that correspond. Addition being the first one. For example, we have question example number 1. We have add 1 2 1 1 3 7 plus 7 1 4 2 1 8. That one being the first example. We are going to add the elements in corresponding matrix with the other. For example, this matrix A, we are adding matrix B. The elements are these numbers that are arranged in columns and rows. First of all, we will take the first element, we add the first element from the second matrix. 1, it's going to be 1, we add 7, that's first one. We have 1, add 1, then we have 3, add 4. Are you together? Then now we have 2, we add 2, we have 1, we add 1, we have 7, we add 8. That's how we arrange the addition of matrix when it comes to addition. Now when we add, here we are going to have 8, 2, 7, 4, 2, and 15. Is that correct? Now, these are an example of addition of matrix that involves adding of corresponding elements. Are we together? Any question? Now, another example, I want one of you to come and attempt this example and see whether it's being understood. Example 2, we have add, we have addition, 3 1 negative 4, then we have negative 7 1 8. We are adding negative 7 1 negative 11, we have 4 negative 1 2. Who can come and attempt this addition of matrix if it doesn't seem to be hard? Who can come and try? Yes, Anne?
So as Marina has said, we are going to add each element to a corresponding element and the same position. So in this case we have 3 plus negative 7, 1 plus 1, negative 4 plus negative 1, negative 7 plus 4, 1 plus negative 1, and 8 plus 2. So that the result will be 3 minus 7, which is negative 4, 1 plus 1, which is 2, minus 4 minus 1, which is negative 6, then we have negative 3, then we have 0, then we have 10. So that will be the answer.
Wow. Let us appreciate her. Thank you so much. And actually, she has done it correctly. This is how we add the matrix when it comes to addition of the corresponding elements. You add the first column with the first element of the second matrix. Are we together? That is very good. Now, I want us to do this. Work it out with your neighbor. Add this. Negative 7 1 7 3. We are adding negative 11 1 4 3 1 7. Now discuss with your neighbor and come up with the answer. Tell me the answer. Discuss with your neighbor. Then tell me the final product, the final answer. Who is ready? The answer? Yes, I want us to do it to get the final answer. Yes, who can can give us the answer after you've discussed with your neighbor? Yes? Yes? Who can read us the values? Yes, sir. Negative 18, negative 5, 10, 20. That's correct. Let us appreciate this group. Good. That's very correct. This is the answer for this addition of matrix. Are we together? Now, finally, I want us to do the last part of it, which is subtraction. And on subtraction, it's still going to be the same. It's not something new. We are going to add the same corresponding element in the matrix. We are going to subtract the same corresponding elements in the matrix. For example, number 1, we have negative 2, 4, 1, 3, 7, 8. We are subtracting negative 3, 1, 2, 3, 7, 1. Now, in subtraction, we still do the same. We take the first element in the first matrix, we subtract the first element in the second matrix. Now, we have negative 2, we subtract negative 3. We get positive 1. Are we together? Then we take 4, we subtract 1, we get 3. We take 1, we subtract 2, we get negative 1. Then the last one, we have 3, we subtract 3, we get 0. 7, subtract 7, we get 0. 8, subtract 1, we get 7. That's how we do it. It's just the same thing, but the difference is on the operation. Any question? Any question up to that point? If there's no question, this is now you've understood. Now let me give out an exercise that you need to attempt, both in addition and subtraction. Now, exercise is going to be, one is going for addition, negative 7, 8, 11, 3, 7, 12. We are adding negative 11, 3, 1, 4, 7, 1. The second one is going to be the subtraction, negative 11, 3, 17, 13, 7, 1. We are subtracting negative 12, negative 7, 1, negative 12, positive 7, 4. Now that's the exercise that you need to do. That is the practice exercise that you will be doing. Are we together?
Yes.
Now maybe someone might be wondering, now where will we get the reference for this? Where will we get the reference for this addition and subtraction of what? Of matrix. Now the reference books you can go and refer to is Higher Engineering. Take note of this, Higher Engineering Mathematics by John Ball. The page is 535. When you go there, you will find that we have the addition and subtraction of the matrix. Are we together? Good. Good. Thank you so much. And that has been our topic today. Now I want to ask the question. You tell me, what have we discussed today under matrix? Yes?
Addition and subtraction of matrix.
Yes. We have discussed about the addition and subtraction of matrix. And what did we say about addition and subtraction of matrix? What did we say about the addition and subtraction of matrix? Yes? What did we say about yes?
We have seen that in subtracting and adding matrices,
Yes.
you add them according to the corresponding.
Very good. we add them according to the corresponding elements. That's very good. Clap for her. Very good. Then what else? The last thing that we discussed as our class today under matrix. Very good. Thank you so much, and I wish you all the best. Have a nice